วัสดีครับ In this clip we will discuss about the solution of the test number 6. Okay. In this test we still discuss the problem about the vector. Okay. On the previous test we have defined what is a vector and what is the definition of the component of a vector along some reference axis. In this problem, we will introduce another concept about the unit vector, okay, and how can we apply this unit vector to write down the component of the vector along some reference axis. Okay. Let's first see the problem. The vector A and B have equal magnitude of 5 units. The sum of A and B is a vector 6j. This means the angle between A and B. Okay. So first we have a symbol J and a hat above the J. What is it? This is an example of the unit vector along the reference axis. So let's see. First, let me talk about the vector on 2 dimensions, the 2-dimensional vector. And if we draw reference axis, we have x-axis and y-axis like this. And we say that if we have a vector A, okay, if we have a vector A and we write down the component of A along the x-axis like this, and we write down the component of A along the y-axis like this. Let us define 2 unit vector. In general, unit vector is a vector that have the magnitude of 1 unit, okay, as its name, unit vector. Okay. We can define the unit vector along any direction. Okay, it's not realistic to define the unit vector along the x-axis and y-axis, but it is useful to define the unit vector along the x-axis and y-axis because we can use those vectors to write down the component of the vector along x and y-axis. Let's see how can we do that. If we define vector I and j as a unit vector along the x and y axis. Okay, it means that I and j have the magnitude of 1 and it points along the positive x. I points along the positive x and j points along the positive y direction. Okay, and from this definition we can write down ax as the a cos theta I and ay is equal to a sin theta j, which I will write this as ax I and this is ayj and we can write that A is equal to the AXI plus AYJ. Okay, so this is the usefulness of I and J. We can use I and J to write down the component of any vector along x and y axis. If our vectors are in 3 dimensions, vector is in 3 dimensions. Something like this. This is x, this is y, and this is z direction. We can also define x, I, j, and k. I, j, k are the unit vector along the x, y, and z direction, respectively. And if we have a vector A, we can write this as A is AX I plus AY J plus AK. Okay, so that is the definition of the vector, unit vector, and how can we write out the component of vector using this unit vector. Okay. Now, let's go back to the problem. Say that we have the vector A and B have equal magnitude 5. The sum of A and B is the vector 6J. Okay, 6J. This means the angle between A and B. From the problem, you can see that if we write A as AXI plus AYJ plus AZK. Now we write it in a general situation that A can be the vector in 3 dimensions. Okay, and also B is equal to BX I plus BYJ plus BZK, like this, and we say that A plus B is equal to 6J. It means that AX must equal to the minus BX and AC must equal to the minus BC. So when you add A and B, okay, let's write it in detail that because when you add A plus B is equal to AX plus BX, I plus AY plus BYJ plus AC plus BCK. But we say that the result has only the y component, that is, it has only j, unit vector j left here. So it means that A plus B must be 0, AX plus BX must be 0, and AC plus BC must be 0, which means that we must have this AX equal minus BX and AC equal minus BC, which means that we can say that the vector A and B have a symmetry along the y-axis. Okay, if we write the axis, the reference axis, a little bit different from this one, but if we write down the axis like this is x-axis, this is c-axis, and the y-axis point out of the plane here. This is the y-axis. Imagine that we put the x-axis and c-axis on the screen, and y-axis point outward. Okay, point outward from the screen. We must have that vector. If we write vector A and B, is something like this. This is A and this is B. We have AX and AC like this, and we have BX and BC like this, which means that AX equal to minus BX and AC equal to minus BC. Okay, so if we rewrite this like this is the y-axis, we must have that vector A and B can be written like this. This is the meaning that we say that A and B are symmetric along the y-axis, right? Look, these two figures together. And if the a-axis has the angle, the vector A has the angle theta with respect to the y-axis, and B has the angle theta with respect to y-axis. So it means that the angle between A and B is 2 theta. Okay. The problem says that A and B have the same magnitude, and we have that AX equal to minus BX and AC equal to minus BC. So what we can conclude from this information is that AY must equal to BY. Okay. Why? Because we know that the magnitude of A is equal to AX squared plus AY squared plus AC squared. Okay, with the square root here, and B is equal to BX squared plus BY squared plus BC squared with the square root here. And we know that AX equal to minus BX, which means that AX squared must equal to BX squared, and AC squared also must equal to BC squared. And if A equal to B, we have no choice. It means that AY and BY must be equal. Okay, so we have this condition. And from this, together with this figure, if we from the definition of the component of A along the y-axis and B along the y-axis, we have that AY is equal to A cos theta and BY equal to B cos theta. Okay, which can also write as A cos theta, which means that AY plus BY is equal to 2A cos theta. But we know that AY plus BY is equal to 6 because we say that A plus B is equal to 6J. and ay plus by is the component of the a plus b along the y-axis. Okay, so we know that ay plus by equal to 6. Okay, and we also know that a is equal to 5. Okay. So it means that cos theta is equal to 6 over 2a, which a equal to 5, so it means that this is equal to 3.5, 3 over 5. What we have is that theta is an arc cos of 3 over 5. The arc cos is the inverse function of cos. When we write it as a cos to the power of minus 1, it's not mean 1 over cos. It is the symbol for the inverse function of cosine. It means that if cos theta equal to x, the arc cos of cos to the power of minus 1 of x is equal to theta. Okay, so we have theta is equal to arc cos of 305, which equal to 53 degrees. So 2 theta, which is the angle between A and B, is equal to 106 degrees, which is the answer is 4.